Hi, everyone. Thank you for joining my lightning talk about CodeQL and bug bounty programs. My name is Mikhail. I'm a PhD student at KTH. And this talk based on the last research in JavaScript infrastructure in server-side Node.js applications. And today I'm going to talk about not about details of the paper. I want to talk about CodeQL and motivate you to learn it and use your bug bounty research. What CodeQL is? CodeQL is an open source static analysis engine created by GitHub. You can model vulnerabilities as queries, then and execute, and CodeQL executed against extracted code in database. So if we take a look on this design diagram, you can see that we have some code base that you want to analyze. We have extractor, CodeQL extractor, and it moves some entities in the database. Also, you can write own queries. Yeah, it's here. It's another step of the analysis. You can write own queries. CodeQL take a standard library that also wrote on the CodeQL language. It's a special object-oriented logical programming language that allows us to write queries and standard libraries that describe how the analysis work. So it can add some abstractions for data flow analysis, for call graph analysis, for control flow analysis, and add this extraction based on the information in the database, and execute your query by executor, CodeQL executor, and provide some results in the end. So it allows us to detect known kinds of vulnerabilities in the analyzed code base. CodeQL, how we see later, CodeQL provide many built-in vulnerabilities that you can just run these queries and get some results to detect these vulnerabilities in analyzed application. And also, you can write your own queries to find any exploit primitives. For example, any gadgets, to investigate the code, to learn something about, to know something about code. It works like an Oracle or some database that you ask some questions by the queries and get the data. Take a look on the list of supported languages. You can see many mainstream languages here. I focused on the JavaScript and TypeScript in my research and work more with these languages and standard libraries. But you can use one tool to analyze many applications on the different languages in the different bug bounty targets. Also, CodeQL support vulnerability detection types out of the box for many vulnerability types. It can be insecure dependency resolution, some injections like XSS, command injection, SQL injection, some complex vulnerabilities like insecure deserialization on prototype pollution, and many others. To give you some intuition how the query looks like, I want to show this simple example of the query on CodeQL language. You can see triple of the keywords from where select. Yeah. And in the first line, you can describe, on the first line, you can describe what the data you want to take from the database. For example, here we define variable pack of package JSON type. It means the pack will be contains set all package.json files from your database that you analyze, from your project that you analyze. After that, you can add some restriction. For example, you want to filter out these packages and store some data in another variable by the string type. You write a where part, and it looks like intuitively code. You get all dependencies from the pack. You get a value of each property, store it in the variable val, and after that you try to match it with this regexp. This regexp match the values that contains HTTP or FTP protocol. It gives you dependencies that can be downloaded using unencrypted communication channel. In the previous slide, when I show a list of possible vulnerabilities that you can detect by CodeQL, you could mention that it contains some injections, a lot of injections. Many vulnerabilities, you need some more complex analysis to detect it. For example, for the injection, you can take some source, like a handler of the web request. You can analyze the data flow from the source until it reaches some function, like exec function that execute some command on the system. If attacker can provide own data, own variable in the exec function, it can reach command injection. We can use a taint analysis for that. CodeQL provides a taint analysis primitive out of the box, and you can see the example of such taint tracking analysis on the slide. The query looks very similar. In the query, you write has flow path from the source to sink that holds when you have a path in data flow between source and sink. And for the configuration, you can define source and sink to override special predicates. I noticed that CodeQL is object-oriented logical programming language, and you can write with some classes to extend some classes from the standard library and define own analysis of the overridden methods, predicates of this class. Okay, we can understand a little bit what CodeQL is. How it matches with bug bounty targets. You can choose between client-side and server-side vulnerabilities that you want to investigate. Of course, CodeQL can help with both types of vulnerabilities. I focused on the server side mainly because of bounties. So critical vulnerabilities, usually you can get more bounties for that. And also my previous research also was focused on the Node.js, that server-side framework. So what bug bounty targets could be interesting for you if you want to apply a CodeQL for that? First of all, I would recommend to see on the big tech companies bug bounty programs. For example, Meta has around 200 repositories in the scope on the different language. You can try to analyze by CodeQL all of that, or most part of that. Google offers bounty for and update bug bounty program for open source software projects like a few weeks ago, I think. You can take a look on the new targets in this bug bounty. Microsoft also offer some bounties in .NET Core, that it's open source project, and you also can analyze it by CodeQL. On the HackerOne and on other platforms, you can filter out programs by assets and source code assets. It's most interesting for us. Just find some source code, analyze it by CodeQL queries, and see on the result. Also, executable assets also interesting because for Java or .NET applications, you can decompile it and analyze decompiled code by CodeQL. Why not? Another trick, you can Google, you can search by company name, public GitHub repositories. So most likely you find some open source or forked code that used in the products of the company, and you try to analyze it by CodeQL and use it in your bug bounty reports. Also, I want to mention about open source bug bounty platform hunt.dev. They cover most of GitHub repositories, and give bounties depends on the popularity of the repository and impact of the vulnerability. I use it for the one case. It's not a large bounties, but it still can be useful. And the Rada initiative. I think many of you know about this bug bounty or vulnerability broker. So they also interesting in the critical vulnerabilities in the open source projects. And so, welcome. And bonus part, CodeQL also has own bug bounty program. It works like if you improve some query, if you implemented own query, you can and you found some vulnerabilities by this query, you can create a pull request, and if your changes will be applied in the repository of CodeQL, you can get some bounties for that. So, my story, my current status of the bounties using CodeQL. We found remote code execution vulnerabilities in npm CLI. Now it's part of GitHub bug bounty, and got $11,000 for that, and no CV. It's interesting. Usually it works in the other way around. CV, yeah, sure, but $10,000, no. But OK, for parse server, it's popular application, open source application. I reported it remote code execution by hunter.dev. It's not much bounty, but it works. Also, a few cases now it's under review in the Rada initiative company, and waiting some result and fixes to disclose some details of these vulnerabilities. All of that, it is remote code execution that we found by CodeQL. So, and few lessons that we got from the using CodeQL. Keep in mind that CodeQL is a logical programming language. In some cases, you can be really wondered why it works like this. For example, A does not equal B, and not A equals B. It's absolutely very different meaning of this expression. I will not go by this text. You can, just see it later. It's good to have some large benchmark with vulnerabilities that you want to detect before you started to use a CodeQL. It's good to have some regression testing if you do some changes in the queries. And also you can calculate the metrics, recall and precision metrics. I could say that hierarchical metrics are very important for practice, in practice, because hierarchical metric shows us how many vulnerabilities you actually can find by this static analysis tool. For example, if you have 100 vulnerable npm packages, you run own CodeQL query and show how many you actually detect. So, for example, in original CodeQL query for the prototype pollution that we use in our research detect about 30% of vulnerabilities. And it does not give me any remote code execution from the bug bounty list that I shown before. It just does, it did not detect it. But when we improved recall metric to 97%, it gives us many new vulnerabilities that we found. I could say that precision rate it's not so important. We got a precision rate around 30%, and it's okay. It means you have a 2-3 false positive for 1 true positive, and it's reasonable to verify manually. It's not a problem. It's just maybe half of hour, not much work. And when I mention about source specification, I could say don't worry much about specification of what the source can be. Try to use any function. It saves a lot of time, and usually you can get a reasonable result for applying. So here I show a link how to start to learn CodeQL. You can use it, and our current result. As I mentioned, we published the papers that are accepted on the Usenix Security 23 when we use a CodeQL, and a lot of work in progress. For example, prototype pollution gadget that leads to remote code execution. I'm planning to publish soon. Some pull requests in the CodeQL with improvements of JavaScript analysis that I mentioned. We increase recall rate from the 30% to 97%. I also want to make this pull request soon. Write-ups about vulnerabilities that we found as vendors fixed it. And I'm working on the workshop, on deep dive workshop, CodeQL Secure as Code. Probably I also will publish it soon. If you're interested in this stuff, feel free to follow me in Twitter. I will do some updates there. Also, these slides I will share in Twitter. Thank you.
Thank you very much.